Okay, here's a quick video that I promised you, giving you hints on our break homework, which is from the Regents from June 2017. Now these will all be quick. These are just references in case you couldn't figure out how to get started on some of these. Question 25. This is the remainder theorem. Look that up. Remainder theorem. That's what you use for 25. 26. The weight of a bag of pears at a local market averages 8 pounds with a standard deviation of 0.5. They follow a normal distribution, so that means we can draw the curve for it. 8 is going to go in the middle, and it's going to go 1, 2, 3, 1, 2, 3, and they want to know less than 8.25 pounds. That's just less than 8.25 being our upper. So this is 8.5, so we're talking about from here down. So that's how you choose your lower and your upper. This is very recent. You should be able to do this. If not, check some of the more recent videos on z-scores and normal distributions. Question 27. Factor that. The way that you're going to factor this is with grouping. But what you get is you get something that ends up being factorable at the end too. So you factor by grouping first. And then part 2, you're going to factor one other way. And I think that you should be able to do that. Just be aware that there is a second factoring. 28. Graph below represents the height above the ground, h in inches, of a point on a triathlete's bike wheel during a training ride in terms of time t in seconds. Identify the period of the graph and describe what the period represents in this context. The period is the length that it takes to complete one full cycle. The period is 2/3. Right? As the wheel rolls around and it touches the x-axis, the wheel is rolling over the x-axis. Okay, one full cycle is also the circumference. Now you figure out how to answer that. Circumference, by the way, is the distance around. So from here to here again. I mean, tighter into here, but you get the idea. Graph this on the axis below. Calculator, second graph, table, and plot those values. Solve algebraically for this. I'll give you the first step, minus x minus x. I'd rather do it like this. That's a little messy. That crosses out. And then you have to square both sides and continue on from there. This is a little 1 on it, this is a 1, and this is an invisible 2. You should know how to create these into fractions. That's the first one. Question 32. Data collected about jogging. We did this question in class. I'm not giving you any hints on this one. We did this one in class. Whether with 2 older siblings is more likely, higher probability, than if one sibling jogs. So these are both givens. Given both, given one. So when we say given both, what we're saying is ignore all the other data, because we're only talking about this column here. So that should tell you what your total is. Your total will be 1780. Okay? That's the idea. So it should be a probability out of 1780. So for the given both, student jogs is 400 out of 1780. Question 33, I'll just tell you to look back on my YouTube for a video called 3 variables systems. Okay, that should be approximately the name of that video. Don't do 34. 35. The way that you can get this into your calculator table in order to graph it is you split the base down and the context up. So this becomes log of 2, that's down, okay, and then log of x plus 3 goes up. And then you bring down the minus 5. So graph this in your calculator and go to the table, and that'll give you the values that you need to plot to go on here. Describe the behavior. What they're talking about is end behavior. So end behavior is like as x approaches -3, f of x approaches -infinity. And I think that's actually correct for the first one, though I am doing this quickly. And then you also have to say as x approaches infinity. Put that in there too. And tell me what f of x does. It goes to what? Last but not least, question 36. Charlie's Automotive Dealership is considering implementing a new check-in procedure. The dealership will launch the procedure if 50% or more of the customers give the new procedure a favorable rating. Each dot on the graph below represents the proportion of customers who preferred the new check-in procedure. Each of the sample size 40 simulated 100 times. So this whole graph here is assuming 50% prefer the new check-in. So this is assuming, this whole graph here is assuming that that's true. Now, assume that the set of data is approximately normal and the dealership wants to be 95% confident of its results. You know what this looks like. 95% confident. Our mean is 0.50, so our mean is here. And the standard deviation is 0.07. So we would go up 0.07, so 0.57, and then 0.64, and that's the top. We'd go down 0.07, so this would be 0.43, and then 0.36, and that's your other 90, so it's 0.36 to 0.64. That's your 95% confidence interval. So they want to know first the interval, which we just did. Round your answers to the nearest hundredth. And then 40 customers are selected at random to undergo the new check-in procedure. And the proportion of customers who prefer it is 32.5. Is that in the normal range? That's the question they're asking you. Okay? So good luck.